Good morning, everyone. Welcome back to Math Made Easy sessions. In this session, I will start talking about rotation. You already learned about how to rotate figures in geometry, probably. But today we are going to see how we are going to do that algebraically with math and trig. So I divided this topic into two videos. In the first one, I'm going to use rotation by 90 degrees, either clockwise or counterclockwise. And that's because it's easier. And then for those of you who want deep understanding, if you are going to become an engineer, a scientist, a mathematician, maybe you would watch the second video that would help you figure out what if I'm rotating about any other angle? Or even instead of giving you an angle, say 30 degrees or 45 degrees or something, you rotate about a slope. You would say, okay, I want to rotate and increase the slope, say, or make it 2, right? So how would you do that? It's very similar, but before we start, let me first show you the four quadrants. You are familiar with the four quadrants, of course. So here is my x, here is my y, and you know that the x and the y coordinates in the first quadrant are both positive, right? Anything to the right of this line, the y-axis, is positive, and anything above this line for y is also positive. To the left is negative, below is negative for x and y respectively. So when I move to the second quadrant, my x is negative, but my y is still positive. Oops, I was going to write y. When you go to the third, meaning left and down, both would be negative, the x and the y. And finally, when you come to the fourth, x is positive, but y is negative, so you get plus, minus, signs. So you can see that that's the first step. The second step is to look at any line, say in the first quadrant. Let's have a line here. And let's say this angle is theta. And then I'm going to rotate it, let's say counterclockwise 90 degrees. And since the sum of these three angles is 180, and this is 90, then these two are 90. If one of them is theta, the other is 90 minus theta. What does that mean? It means that these two angles are complementary angles. They add up to 90 degrees. And we learned that sine theta equals cosine 90 minus theta, or pi over 2 minus theta. In your head, since we are always measuring the angles from the x-axis, either this way, that way, or that way, then cosine is related to x and sine is related to y. Meaning, if I want to find this side, I multiply this length by cosine to get the x, by sine to get the y, because the y is opposite. So basically what we are saying here is that if I rotate a line 90 degrees counterclockwise or even clockwise, the cosine becomes sine, meaning the x becomes y and the y becomes x. So for example, if I have a point here, let's say 3 and 2, and I rotate it 90 degrees, it becomes 2 and 3. Is it? Not exactly. Why? Because we said in the second quadrant, the first coefficient is negative. So it becomes negative 2 and 3. If I rotate it another 90 degrees, The 2 and the 3 reverse and become 3 and 2. But guess what? Negative and negative. So negative, negative. And then when I rotate another 40 degrees, they switch back and they become 2 and 3. But again, guess what? The second one is negative, so that's a negative. If I turn 90 degrees again, I go back to where I started. The 3 and the 2 cancel or switch, and both are positive, so I get the 3 and the 2. So that's how easy you can rotate 90 degrees either. If you are going counterclockwise or positive, we refer to the counterclockwise rotation with a positive sign and clockwise as negative. So if you rotate 90 degrees counterclockwise, you see what happens? You switch these two and change the sign of the one at the front, the first one, the X. So the 3, 2 becomes 2, 3, but the 2 becomes negative. Then I switch again, the 3 and the negative 2, and I make the 3 negative. So now both are negative. I switch again and make the negative 2. I change its sign, so it becomes positive 2 and negative 3. Positive 2 and negative 3. If you are going clockwise, it's the other way. You switch the X and the Y and change the sign of the second. This was a 3, becomes negative 3. This is a negative, so you switch. This is a 2, it becomes negative 2. You turn, the negative 3 becomes positive 3, and so on and so forth. So it's trivial rotation about the origin. But what if you want, say, to rotate let's say you want to rotate a point, any point, you can pick any point, 4 and negative 3, for example, 90 degrees, say clockwise, around, and instead of the origin, you pick any other point. Let's say around 2 and 1. How do I do that? I do 3 things, 3 steps, very simple steps. What are they? I say, if that was the origin, I can rotate very easily and make that negative 3 and negative 4 because I'm rotating clockwise, so I'm going to change the sign of the second entry. When I switch, the second entry would be 4, so I make it negative 4. Think about it. 4 and negative 3, it means I am here. So when I rotate clockwise, I will be here, and both would be negative. But the problem is I'm not rotating about the origin. I'm rotating about a point that is 2 and 1. So you'd say, okay, I'm going to play a game. I'm going to move this to the origin and see if I move it to the origin, where would that end up? Then rotate it about that fictitious origin. And then say, oh, I rotated, excuse me, I rotated it after moving it, so let me return it back, return this back and this back to where they were, or where they would be. And you say, oh, it's so complicated. No, it's not. I'll show you how easy it is. Mathematically speaking, how do I make this the origin? The origin is 0, 0, right? Meaning, I subtracted 2 from the x and I subtracted 1 from the y. So let's subtract 2 from the x and let's subtract 1 from the y. So now it became 2 and negative 4 instead of 4 and negative 3. Step number 2, rotate about this point clockwise, meaning switch the 2 and the negative 4, but then make the second one negative. I'm done. See how easy it is? And then you say, oh, but that's not the answer. Notice, I moved this point to 0 and 0. So to return it back, I'm going to add 2 and add 1. So let's add 2 and add 1. I end up with negative 2 and negative 1. That's it. You see how easy it is? You can check my answer. Maybe I did something wrong. I have 2 things that I know for sure if I did it correctly, they would be true. What are they? If we call this point P and that point P prime, and this is the origin, and this is the origin prime. I don't care about the origin. I have to say that the distance from P to O prime, notice that was the original point, and that was the point I wanted to rotate. So after I rotating it, the distance O prime P prime should be the same. It didn't change. I took a line and rotated clockwise. So why would the line change? So check number one or check one, I check O prime P and get the distance. X minus X is 2 and 2 squared. Negative 3 minus 1 is negative 4, so plus 4 squared equals square root of 4 plus 16 equals root 20, or if you want, 2 root 5. Now let's see here. So, what did we say we did? We added 2 here. Okay, so now the distance from O prime to P prime, from 2 to negative 4 to negative 2 is 4 squared. And from 1 to negative 1, it's a distance of 2. So plus 2 squared, again, it's equal 16 plus 4 or root 20 or 2 root 5. So it's okay. That's not enough because maybe I rotated 180 degrees, not 90. So how do I check the second thing? I know that the slope of O prime P and the slope of O prime P prime should be, the product should be negative 1, meaning 1 is the negative reciprocal of the other. So let's say slope of O prime P. I notice it's the change in y over the change in x. So if I go from, it doesn't matter where you start, but be consistent. So if I start from here and say the y change from negative 3 to positive 1, that's an increase of 4. I have to start with the 4 and say going from 4 to 2, it's a decrease of 2. So the slope is negative 2. I could have started from 1 to negative 3 and say that's a decrease of 4 divided by 2 to 4, it's an increase of 2. So negative 4 over 2, I also will end up with negative 2. It doesn't matter. Now, how about the slope of O prime P prime? I go from 1 to negative 1, that's a decrease of 2, over from 2 to negative 2, that's a decrease of 4, so it's 1/2. And sure enough, if you multiply 1/2 by negative 2, you get negative 1. The last thing is that somebody would say, so this is check number 2. Check number 3, which is because maybe you rotated 90 degrees, but you went counterclockwise, not clockwise. The original point was 4 and negative 3. 4 and negative 3, meaning here. And when you rotated, if you rotate clockwise 90 degrees, you should end up in the third quadrant, meaning both are negative. Yes, both are negative, so I really rotated clockwise. If they were both positive, it means I did it incorrectly. Okay, so that's a point. Most of the time you don't want to rotate a point, but maybe you want to rotate a line or a conic section or something like that. So let's see how we rotate a line. So you don't need to write that. Let's put it down here, make an example. Rotate. Let's take something easy. Y equals x plus 5. We're going to rotate it, as we said, here we only do 90 degrees today, okay? Because that's what you will be doing. And let's rotate it counterclockwise, okay? And when I rotate it counterclockwise, I don't want to do it about the origin. So let's make it about another point. Let's take a 4 and a negative 2, for example, just any 2 points. Remember what we did in the previous problem. I could do it again, meaning if I have this straight line, the y-intercept is 5, slope is 1, so I get something like that. That's the straight line y equals x plus 5. Notice I cannot just pick a point and rotate it. I have to pick 2 points because that's a line. A line is defined by 2 points. So I could have done it, but this would be too tedious. So I can pick a point like 0 and 5, and then maybe 1 and 6. Rotate this about this point, meaning subtract 4, add 2, and then change the x, and we are rotating counterclockwise, so we'll switch the x and the y and change the sign of the x, and so on and so forth, and then return them back. And then after returning back the 2 points, you use them to construct a new line. It's a lot of work. So what is the shortcut? The shortcut is that we are going to use the 4 and the -2, but instead of using them with points, we are going to use them with an equation. So what is the difference? Everything would be reversed. What do you mean? Remember what we did in the previous problem? We subtracted 4 from the x and we added 2 to the y. So here we are going to say, no, I'm going to do the opposite. So instead of y, I'm going to say y minus 2. And instead of x, I'm going to say x plus 4. And there is another 5, so x plus 5. Bear with me. This is the first step. So this can be written as y equals x. When I add 2 to both sides, I get 11. That's step number 1. Step number 2, remember, so this was step number 3 there. If it's not the same, but we were adding at the end and subtracting in the beginning. And in the middle, we were rotating counterclockwise. But here, I'm going to rotate clockwise, the x and the y. You say, why? That you may learn that this is more advanced. It needs more thinking. So maybe I will touch on that in the next video, in the next session. But for now, just take it from me and we can check the answer at the end. But we do the opposite. So in the beginning there, we subtracted the x and the y. Here we added them. So we added 4 to the x and we added -2. There we rotated each point, we rotate counterclockwise. Here the x and the y, we will rotate them clockwise. When we rotate them clockwise, what happens? Do you know? For every x, I'm going to write it as a y. And for every y, I'm going to write it as a -x. Okay? So the y here is -x. The x here is y plus 11. So I can write this equation as x plus y plus 11 equals 0. And finally, there we added the 4 and the -2 to the x and the y. Here we subtract them. So we can say x minus 4 plus y minus -2 plus 11 equals 0. So I get x plus y. There is a -4 plus 2 is a -2 plus 11 is +9 equals 0. We write that usually as y equals -x minus 9. This equation right here, um, You see that the slope is -1. And here the slope is 1. So that was 45 degrees. That's negative 45 degrees. So they are perpendicular to each other. We can pick any point. Let's say we said 0 and 5, for example. Let's rotate this about that point and see where we end. If where we ended, the point is on this line, we did it correctly. If not, then we did something wrong. So if I take 0 and 5, remember what we did first. We said we wanted this to be the origin. So I'm going to subtract 4 from the x and then add 2 to the y. So I get -4 and 7. And then I'm going to rotate counterclockwise. So I'm going to switch them, 7 and 4, and change the sign of the first. So it's really -7 and -4. Okay? And finally, I'm going to add these. So I will get, if I add 4, I get -3. If I subtract 2, I get -6. Is this point on this line? Y is -6. Left-hand side is -6. Right-hand side is negative x, but x is -3. So -3 is +3 minus 9. Yes, 3 minus 9 is -6. So it's correct. So I proved that they are perpendicular to each other. And if I pick any point on the original line and rotate it about this point 90 degrees counterclockwise, I will end up on that line. So I checked my work. Perfect. One last thing. Let's pick something because straight line is easy. So let's pick something more involved. I'm going to say, let me start with an ellipse. And this ellipse is x squared over 16 plus y squared. I want to make this 4 and this 3. So 3 squared is 9. And 9 times 16 is 144. So if I want to rotate this, what did we rotate this? This was counterclockwise. So let's rotate that clockwise, 90 degrees clockwise. And again, we could have done about the origin, but let's pick another point. So instead of the origin, let's pick -2, -3, whatever. Just for simplicity, I'm going to rewrite this equation. If I multiply everything by 144, this would be 9x squared plus 16y squared equals 144. And I'm going to do exactly what I did last time. I'm going to add these coordinates to the x and the y. Notice there we subtract when it's a point. So 9 times x, and then I'm going to add -2 squared plus 16y, and then I'm going to add -3 equals 144. That's the first step. So step 1. Step 2, remember step 2? For the x, we're going to make it -y. And the y, we're going to make it x. The opposite of what we did when we were rotating counterclockwise. So let's rewrite those. The first one would be 9 -y minus 2 squared plus 16 x minus 3 squared equals 144. That's step number 2. Then I'm going to subtract those. But before doing that, because this is a negative, do you know that -y minus 2 squared is the same as +y plus 2 squared? Try it on your own. It's easy. When you have a square, it doesn't matter. You can either say x minus y squared is the same as y minus x squared, because you are going to multiply by -1 squared, which is +1. So really didn't change anything. You could write this as -1 times y plus 2 quantity squared. So the -1 squared is +1 and the y plus 2. It's easier, so you don't get confused here. Do you see that? Hopefully, if you do it manually, you will see why that is correct. It's a even function. So at the end of the day, we are going to subtract these. Notice, this is a y plus 2. A y meaning I'm going to subtract -3. So it would be +3 square plus 16 x, let's say the -3, and then I'm going to subtract -2, meaning I'm going to add it to square equals 144, meaning 9 times y plus 5 square plus 16 x minus 1 square equals 144. That's the equation. If you want to divide it by 144, you will get y plus 5 square over 16 plus x minus 1 square over 9 equals 1. This is an equation of an ellipse that has the major axis along the y. This was the major axis along the x. Again, the semi-major axis was 4 and the semi-minor was 3. Here stays the same, but vertical versus horizontal. And we moved the center from the origin. It moved to 1 and -5. And you can check. You can pick a point. Like I know that here, for example, maybe 0 and 4. So this ellipse looks like that. This point is 0 and 4. I'm sorry, 4 and 0. Why did I say 0 and 4? Sorry. 4 and 0, and this point is -4 and 0. This is 0 and 3, and this is 0 and -3. What happened is that after I rotate that clockwise about a point -2 and -3, which is a point here, I ended up with an ellipse that has the center at 1 and -5. This is 3 to the right, so it's 4 and -5, -2 and -5. I went up 4, so 1 and -1, and 1 and -9. I ended up from here to here. You can do it as your homework, is to pick any point out of these 4 or even the origin and rotate it about this point 90 degrees clockwise and see if this point becomes that, or 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 the origin becomes that. That's your check. And you can check 2 of them, maybe these 2, for example, just to make sure that you didn't rotate the other way around. I hope this was an easy session, pretty straightforward. I gave you how to rotate a point, about the origin or about the point, about another point. And then I said, when we move to a figure, like we did a straight line, we did an ellipse, and we use the exact opposite steps. There are 3 steps, but we do them backwards when we deal with an equation, not with a point. If I pick 4 points, I could come up with these 4 points, but you see how much work we do? Each point of them, you assume this is the origin, so you add these, you add 2 to the x, 3 to the y, then you rotate clockwise by switching the x and the y, changing the sign of the y, and then you add these points back, and then you repeat it 4 times to get these 4 points, and then you try to construct the the ellipse from these 4 points. It's a lot of work. Here we didn't have to deal with 4 points. We just looked at the function itself or the equation itself. We applied 3 steps and we ended up with um, the new form. Okay, I hope this was clear for you, and hope to see you in the next session of Math Made Easy. For those of you who want to watch the advanced session also, I'll try to do that soon, maybe today or very soon. Thanks for your time and have a great day.